Good afternoon, everyone. I am Jiani Xiao. I'm from National Sun Yat-sen University, and my project is Dual Loop FVFLDO. And I divide the contents into 4 parts. First one is the motivation, and the second one is the operation principle, and the third one is the results. Last but not least is the conclusion. First, motivation. And according to the picture, it shows the overall system of concrete smart card. And dual loop FVFLDO is applied to ADPLL, format TDC and DCO. And the overall dual loop FVFLDO is used in concrete smart card. And next, we will talk about how the concrete smart card would operate. First, the phase modulated signals from LA and LB are converted to square waves via an antenna buffer, and the square waves would induce high-frequency noise in the system, and it could disrupt the microcontroller and leading to data errors or loss. Hence, our objective is to ensure TDC in ADPLL maintains less than 1 least significant bit variation, which is our power fluctuation is less than 20 millivolts, and that is to attain minus 40 dB PSRR. Hence, we need to design a high power supply rejection ratio LDO to provide stable voltage. At this part, we will talk about how our circuit would operate. And according to the picture, our circuit consists of a rectifier and 2 stages of dual loop FVFLDO. And as for rectifier, it contains the comparator and PCE module. And PCE module is fed by an input with an amplitude of 1.6 volts, and the comparator acts like a switch. And when PCE module is under positive half cycle, which means Vy is bigger than Vreference, which will lead to comparator 1 output 0 volts, and it also leads to MP1 and Mn2 are on. And Vy will charge capacitor Cl until Vreference is bigger or equals to Vy. And when V reference is bigger or equals to Vy, the comparator 1 would equals to 1.6 volts, and it would cause MP1 to be off. Conversely, the negative half cycle is opposite to positive half cycle. Hence, the rectifier would provide reference voltage of 1.6 DC volts to LDO. Talk about the first loop of FVFLDO. It consists of OP amplifier, and it would provide stable VMIR at M4 source terminal. Because M3 and M4 are source follower, the VO1 converges to VMIR. And the resistor and capacitor between M3 and M4 will filter out high-frequency noise that will better PSRR and DC gain at high frequency. For second loop, it consists of M3, M5, and M-pass. M3 forms a common gate amplifier. According to common gate amplifier, the inputs would be at source terminal, which is VO1, and the outputs would be at the drain terminal, which is VA. Hence, the variation in VO1 would be reflected to VA, and it would fed back to MG through M5. To sum up, the input signal is corrected through dual loop to reduce voltage variation and minimize distortion. And let's see the pre-layout simulation of PSR under worst case. And the picture shows the results. And the next is the post-layout simulation of power supply rejection ratio under worst case. And after calculation, we could analyze that all of the precinct results are below -40 dB, and whereas the post-sync results are worse than precinct. And I assume that it is due to parasitic resistor and capacitor in the layout. And next, let's see the pre-layout simulation of power supply rejection ratio under high frequency. And the next is the post-layout simulation of power supply rejection ratio under high frequency. And after calculation, we could analyze that both pre-sync and post-sync results are below -40 dB, which means the circuit minimizes distortion and output voltage variation. And we can see the results also in the output simulation. And the picture shows the pre-layout simulation of output voltage, and it is tested under 8.3 million Hz, and the loading capacitor is 4.7 microfarad. And next shows the post-layout simulation of output voltage under 8.3 million Hz. And according to the pictures, we can hardly see the variation in the output voltage. It verifies the results of PSR under high frequency. And next, the picture shows the layout of rectifier, and whose area is 29.9 multiplied by 57.65 micrometer squared. And next is the first stage FVFLDO layout, whose area is 143 multiplied by 164.76 micrometer squared. And next is second stage FVFLDO layout, whose area is 201.52 multiplied by 132.9 micrometer squared. And according to the figure, it shows the results of specification. And pre-layout simulation of PSR are -50.2 dB, and the post-layout simulation is -30 dB. And it is due to what I previously said, the layout, parasitic resistor, and capacitor. The last part, I would talk about what I learned during the project. First, when I encounter problem, I learned how to solve it via reading paper, and also I learned how to adjust the circuit via checking H-spice and the transistor's property instead of trial and error method. Last but not least, I get more experience about design rule check and LVS rules from multiple types of alterations. And that's all for my project. Thanks for your listening.